so much for joining. We will talk about programming with ServiceLoader API. So let's talk a little bit about what this is, and then we will dive in and take a look at what it provides for us. Before we talk about ServiceLoader API, in Java 9 specifically, they introduced the concept of modularization. And so you can create Java modules or modules in Java. And what it really means is, let's step back and think about what modules provide. And then, having set that context, we'll talk about what Service Loader actually provides for you. Now, let's think about the time of Java 8, way before Java 9 modules were introduced. In Java 8, we had jars in the class path. And when you have jars in the class path, any code in any jar can use any code in any other jar. Anything that is declared public was wide and open. So what does that really mean? You had no concept of encapsulation. Any code written by anybody is available to anybody. You didn't have a way to say, this is for my purpose, you cannot use it. But when it comes to design and architecture, that's not a good idea, because if you're an architect, if you're a senior programmer, and you want to structure your application and say, here are the different subsystems, and this subsystem should access this other subsystem, but it shouldn't breach through the encapsulation and talk to anything you want to, then the problem really is you don't have a way to really manage the complexities of your application because everything is wide open. So with that said, what did Java modules really provide for us? The benefit you got from Java modules is that, think of this like a handshake. If I want to shake your hand, I got to extend my hand. Now, this is a very awkward, embarrassing situation, right? Because this happens sometimes, right? You extend hand to somebody and they're not paying attention to you. And you're like, hello, can I shake your hand? Well, for a handshake to happen, two things have to happen, right? Both the parties have to extend their hand, and that's when the handshake happens. So the idea with modules is, a module can only use what it requires. If it doesn't require something, you cannot use it. But a module can also only use what's exported to it. You cannot use what's not exported. So in other words, this becomes a contract. A module says, I've got these packages, and of the 7 packages I have, I want to export 2 packages. The other 5 packages are my internal business. Nobody should use it. So think of this module now with 7 packages, but 2 of them pointing out, and the other things are internal and hidden, nicely encapsulated. Now this other module says, I want to use this module, so I'm going to require it. So now you have a contract. What's the good news? The good news is you don't have an accidental coupling. You don't have a breach of encapsulation. You got a very clear definition and description of the dependencies. If I give you a jar file and ask you, what does it use? You don't throw your hand up and say, good luck, I have no clue. You can clearly say, this jar requires these other jars, and these jars can use this jar, and your dependency is very clearly laid out. So this is a nice, beautiful world, but this is great, but where does this fall apart? The rigor is amazing. You're able to clearly define your dependencies. Users of a module can say what they want to use. Providers of a module can say what's available for others to use. And we have intentional code, clear description of contract. Aren't we all happy with it? So this is good for 99% of the situation. And that's not what we're going to talk about today in this talk. We're going to talk about that 1% where that is not sufficient. Like what? So there are different architectures that are out there. You could be building monoliths, for example. You could be building modular monoliths. You could be building microservices. You could be building client-server architecture. You could be building service-oriented architecture. You could be building pipelined architecture, event-based architecture. For everything I mentioned, what I talked about is good enough. Because in every one of the things I talked about, you can clearly say what you want to use, you can clearly say who can use it, and the contract is good enough. But there is one architecture where this is not going to be enough. Think of the example of Eclipse. Think of the example of PMD. Think of Jenkins. Think of, as a concept, Google Chrome. What architecture did I just describe in all of these? What was that? Bingo. Plugin architecture. How does a plugin architecture work? In a plugin architecture, what you have is what's called a core, right? So you have a core. The core says, I am going to provide a core set of behaviors, right? So your core is sitting right there. And then you can provide a plugin P1, plugin P2, plugin P3, and so on. And all these plugins can implement a certain part of your application. Plugins usually come in two different flavors. You can have technology-based plugin, or you can have a domain-based plugin. For example, one plugin may say, I'm going to give you credit card processing service. Another plugin may say, I'll provide you bank transfer facilities, so you can pay through a bank transfer. A third plugin may say, I'll issue a loan on demand. So these could be plugins that take care of payment processing, and you may throw in plugins at runtime. And what is the characteristics of plugin? Plugins are dynamic. And when plugins are dynamic, you want to be able to pull things at the runtime dynamically and be able to use them. And you don't want to know who those are ahead of time. Plugin architecture will fall apart if you have to tell what the plugin implementations are. Because then you're going to be sitting and reconfiguring, recompiling, the worst case, and you got to do redeployment. And in plugins, at the very least, you don't want recompilation. At the very least, you don't want to modify your code to say what your dependencies are. At the very best, you don't even want redeployment. You do a hot plugin, you throw in a plugin, and the application says, whoa, look at that, I'm going to pick it up and run with it, and you can continue moving forward. So the scenario I described earlier, where you have a really thorough, rigorous contract of a handshake, is no longer useful for the plugin architecture. Because a plugin architecture requires dynamic discovery, right? So we are talking about modules, but the 99% situation doesn't apply to this 1% situation when you're doing plugins. So good news and bad news. The good news is don't use this for creating plugins. Bad news, don't use this for regular modules, because this is too complicated and useless when you can define clear contracts. So will I use this for building microservices? Probably not. But will I use this for building plugins? Most likely yes. So now, how did we manage plugins in the past? In the past, when you want to do plugins, you will have implementations of interfaces, and you want to be able to use those implementations at runtime in code. What technology would we use to dynamically discover these objects and use them? Any try? IOC is the design principle, but code level, what would you do? Bingo, reflection. Raise your hand if you love reflection. Okay, these people need help, right? The rest of us, not reflection like looking in the mirror, right? Because the minute you do reflection, what do you deal with? Well, actually it's not. That's a myth, right? We tell ourselves that this is like the moms and the dads who said, if you touch that, it'll burn your hand. Oh my gosh, I won't touch it. So everybody freaks out performance. Have you really seen a performance problem with reflection? Not really. you deal with 20,000 exceptions, right? Class not found exception, method not found exception, this not found. And by the time you get through this, you forget why you started writing this code, right? Your code is a monster looking in front of you, right? The reflection code is, so you need dynamic discovery and you're using reflection. It's not clean. It's not hygienic, right? You don't go home and show this code to mom, right? You don't say, Mom, look at the code I wrote today. Do you expect mom to say, that's awesome, right? Mom says, you need to grow up. Don't write code like this, right? Because that code is not elegant. That code is not revealing intention. There is all these, for name and, casting and phone rings and all that. So all that is so overwhelming, you don't have clean code when you deal with reflection. You want to program with intention. What if I can simply say, I want something, give it to me, and things just work? So that's basically the idea. Now, having said that, this is what I call it myself. I call this the well-kept secret. I call it a well-kept secret, not because it's a secret, because I didn't know about it. As it turns out, there is a class called ServiceLoader. And the ServiceLoader was introduced in Java 6. I never knew this. Anybody who has used ServiceLoader in Java 6? This is why I said it's a well-kept secret, right? It was there and nobody knew about it. And I came to know about it accidentally in Java 9, and I look at the documentation, it said introduced in Java 1.6. I'm like, really? And it's been there, and they rewrote it in Java 9. And here is how, what does a service loader really provide? Fundamentally, if you want me to use a crisp word to describe it, it's a broker. And look at the music, tone changes now, right? For reflection, you had that little alarm going off. Now it's a beautiful music, right? So you can see the reflection of how this is beautiful concept. It's a broker. So the broker says, hey, you want something, and you ask what you want, and I'll give you the implementation, and I'll broker it, connect it. You want clean code. But not only clean code is not good enough if it's an insecure code. If you are writing some code, you call somebody's function, they call my function, and I'm like, aha, I'm going to start pulling in dependencies in code. And you're going to say, dude, what are you doing here? Well, I pulled in all these dependencies. Well, you didn't have rights to do it. I never gave permission for you to do it. So you want clear-cut permissions. So you want dynamic behavior, but dynamic that shouldn't compromise security. So how can you get something secure and dynamic and clean? That's what we want to talk about. So let's take a look how this is going to work. So what do I want to do? Let's talk about an example scenario that we can work with. So the example is, let's say I want to go to a restaurant and I sit down and I'm thirsty for getting a drink, a soft drink. And the restaurant says, what would you like to drink? And I usually say, can I have a Pepsi, please? And they say, we only give you Coke. I was like, fine, give me Coke. I go to another restaurant and they say, what do you want to drink? I say, give me Coke. And they say, we only have Pepsi. There's no way to win this battle. Maybe we should just drink water that's healthy anyways, right? But how can I abstract this out? I am going to say, give me something really sugary and unhealthy. How do I say that? Give me a soft drink. So soft drink is an abstraction. So when I say, hey, I'd like a soft drink, please. And the restaurant now says, well, we got these products. Which one would you like? And I can say, oh, among those products, I'll take Coke, please. Or I'll take Mountain Dew, please. I'll take, whatever, right? Make sense? But the company says, we're going to introduce new soft drinks. And when we introduce new soft drink, we don't want you to change any code at all. You want to run the code tomorrow and the new soft drinks pop up. And the customers in the restaurant can pick what they want. We decide to abandon a soft drink. We don't want to buy things from this vendor. And the next time the customer sits in, it doesn't show up. Fair enough? That's the use case we're going to work with. So how do we program with this right now? So let's take a look at an example of how we can do this. So first of all, I'm going to create a soft drink. And within this soft drink, I'm going to say let's say slash. well, we'll say, agile developer, and then I'm going to say soft drink. That's going to be my directory that I'm creating right now. So within this directory, what do I want to do? I'm going to go to the soft drink, and I say soft drink. Let's go ahead and say soft drink dot Java. I'm going to create that. So my package right now is com agile developer, and I'm going to say soft drink. And within this, I'm going to say an interface. Well, it better be public, right? So public interface. And what do I want this interface to be? A soft drink interface. And within the soft drink interface, I'm going to say, let's say, a get name for the soft drink and get me the size of the soft drink, maybe just 2 functions, right? So that's my abstraction that I created, that I have a soft drink, and I can say, what's the name of the soft drink? Whatever the name is, I could say, what's the quantity of it, right? Tell me how many ounces it is, how many milliliters it is, and I can find that out. So that becomes the abstraction. So I have an interface here in the soft drink directory, as you can see, but within the soft drink directory, I'm also going to create a module info.java. Well, as you probably know already, module info.java is the module descriptor where you're going to specify your module, what's your module's name, what does it export, what does it use, all those good stuff. If you're doing regular modules, in this you're going to say what you require and what you export. But as we talked about, while that is really powerful, that's too rigid for us to be using in this case. So what are we going to do? So in this, what we're going to do is the module that I'm interested in doing here, and I'm going to simply say the module is a soft drink module. That's the name I provided for this module. And what does this do? It exports the com agile developer soft drink package. So that's basically all we did, right? So we are saying that we are exporting that particular package. That's all we are doing. So let's take a look at the build.sh. I'm blowing away everything from the output directory. I'm going to run a Java C on it, compile everything from the soft drink directory, and bundle that into a soft drink.jar. And when I'm done with it, I'm going to output ls, let's say lib, so we can see what's in that directory. That's all I did, right? Nothing really exciting. So let's go back and take a look at it. Soft drink.jar is sitting right there and ready for us. So far, so good? All right, now what do we want to do? Our next step here is I'm going to say, let's say in this case, let us run a client without, let's say, without any provider. So I don't have any provider right now, but I want to run my client right now. So I'm going to grab those 3 lines, and I'm going to run a client code and bundle it to a client.jar. And then once I'm done with it, I'm going to say Java minus module path output lib directory. And what do I want to run? I want to run a client. That's what I want to run from here. So client. And the client I want to run is com agile developer. We'll say agile developer. And let's call this as client.client, right? So that's what I want to run. So I want to run a client code and see how that works. So let's get to that right now. So let's make directory right now. And I'm using very fundamentally everything on the command line. Nothing is hidden behind my sleeves. So you got full clarity to what I do. So I'm going to say client com agile developer. And this is the client. And I'm going to say client. And let's create a client, client.java. So the package is com agile developer client. And what am I going to say? Import, right? And what am I going to import? I'm going to import the com agile developer soft drink dot soft drink, because I want to bring in the soft drink. So our class that we're going to create right here is going to be the client class. And what am I going to do within the client class? So let's do a public, let's say, static void main and the string arguments right there. And what do we do with this particular string, with the main? We are going to say, let's, look for soft drinks. So I want to know what soft drinks are available, right? So we want to know what's available. So how am I going to get to those soft drinks? We'll get to that in just a minute, right? We'll come back and write this code a little bit more in a second. So I'm going to edit, and this is going to be the client, and again, module info.java, and you create a module called the client module, right? That's what you want to do here. And what does a client module require? Requires the soft drink module, right? So you bring in the soft drink module. But in this case, you're going to say uses calm agile developer soft drink dot soft drink. That's your contract. So you are saying, hey, your broker, I want you to know that I authorize you to look up implementations of soft drink. So if my code all of a sudden says, ServiceLoader, go find soft drink, the service loader says, excuse me, you never granted permission for me to do that. So this may be malicious code, I won't do it, right? So the users basically grants permission. I'm declaring my intention. So if I give you a jar and say, what does this jar do? Oh, that jar is interested in finding implementations. It's a code that's going to rely on the broker. That information is revealed by this one. So far, so good. So that's what we specified right there at this moment. So let's go ahead and see what it's telling us. So in this case, I'm going to go back to the build file right now. And in the build file, I need to bring in the directory where we're going to compile these stuff again, because I want to put that into the classes directory. That's where I'm going to put this. It says requires soft drink, and it's like complaining, what in the world are you talking about? I don't find it. So I'm going to say -p output /lib, because that's the module path where the soft drink is located, right? So I'm going to bring that in, and it says, let's look for soft drink. Now it's time for us to actually write the code, isn't it? So what are we going to do right now? So in this case, I'm going to go to the client, and in the client code, I'm going to say import, and guess what? Import java.util.serviceLoader. Like I mentioned, that's been around since Java 6. And that's exactly what's been sitting in the Java util. So Java util saw a service loader, and we are asking for it. So what are we going to do here? I'm going to say over here, soft drinks equal to service loader.load soft drink dot class. So I'm asking, hey, could you do me a favor? Just go around, look in your module path, and find everybody who's implementing that interface and bring them over to me. How many implementations do we have right now? That's right, 0, right? Correct. So then for, and we'll say soft drink coming from soft drinks. And what do I want to do here? I want to simply say output soft drink dot get name, and I want to display it, plus let's go ahead and say a soft drink dot get size, so we can print it. So that's basically what we're going to output right now. So right there, it listed nothing because there's nothing existing, right? So it's like, I'm done, I don't have anything. So that's our client. So let's get back to the build, and we displayed all those clients. And as you can see, there is really nothing to display because we don't have any providers. So far, so good. All right, now what are we going to do next? Let's grab those 4 lines of code. Let's bring that in here. Now I'm going to compile a particular soft drink. So we will look for everything under Coca-Cola, right? And I'm going to bundle that into a Coca-Cola.jar, and I'm going to bundle that into that jar file. That's all we're going to do. Once we do, what I would like to do is, I'm going to say, let us run the client, in this case, with one provider, right? So we're going to run it with one provider. So I'm going to run this again. And in this case, just rerun the client, right? Notice the client doesn't have anything different. I'm not going to touch the client anymore until we go further. So I'm just rerunning the client. So what's going to happen this time? That's the question. So let's create a Coca-Cola directory. And within this Coca-Cola directory, we'll say calm agile developer, and we'll say Coke. Or we can say, yeah, Coke is good. And within this, we will say calm agile developer Coke.java, right? We call it Coke. So package in this case is, what is this? Calm agile developer, Coke is the package. And what are we going to do in this case? It's going to be import calm agile developer dot soft drink dot soft drink, because this is going to implement that interface, right? So public class Coke implements, it's an implementer, right? Implements the soft drink interface. And so what does that do? It says a public string get name, and what's the name going to be? Return, let's say a Coke, right? That's what you want to return. And I want to return a size. So we will say here comes a size, and this is a get size. Oh, let's return some size. Let's simply say 12 over here. So that's my function for the implementation of the soft drink interface. What's the next step? The next step here is to go to Coca-Cola. We'll call it as module info.java. And in this case, I'll say module is Coca-Cola, right? Coca-Cola. And what does this module need? It requires, right, requires soft drink. Why does it require soft drink? Because it implements the soft drink interface. That's coming from the soft drink module. You cannot use anything that you didn't require, right? That rule is still there. But what you don't want to do now, you don't want to export your Coke package. Why don't I want to export it? Because I don't want anyone to directly ask for a Coke, right? In this particular case, I want to provide an implementation of an interface by way of discovery, not by way of directly coupling to it. But on the other hand, there is a problem though. If I implement multiple interfaces, is it possible that I'm implementing an interface right now, but it's not ready for production? Does that ever happen? All the time, right? Because you're writing code and you're like, no, it's not ready yet. We are still working on it. You may write an implementation for testing purposes. This is purely a stub, and I want to bring it in and test it. This could be an implementation you decide to throw away. You don't want anyone to use it anymore. We're just waiting for final confirmation to delete it. Those are three candidates, for example. You don't want somebody to start receiving it. So in other words, what you have, you need to control whether that should be available or not. So how do you specify that? The way you specify that is, you say over here, provides what? Com agile developer dot soft drink and with, this is going to become agile developer Coke. So you are saying, hey, I am going to provide an implementation of the soft drink by way of my Coke. And I want you to know that anybody who wants an implementation of soft drink can get access to it. So that's basically what we are specifying right in there, right? So that's all we did. So now that we did that, what's going to happen? Coca-Cola, it doesn't know what it is. Let me make sure that I've said it properly. Coca-Cola, right? C-O-C-O. So this is Coca-Cola. Let's move that to the proper directory name, and let's come back here and run that again and see what it wants to tell us. Now, did you notice the difference? The second time we ran the client says, oh, look what I found. I found a Coke as an implementation. I didn't touch the client, right? I didn't change the client. And the client says, anybody providing a soft drink interface? I didn't find anyone, so it didn't yield anything. Now that we compiled the module Coca-Cola and put that in the module path, and when we run the client says, oh, look what I found. When I ask for implementation of the soft drink, here comes one, and I can use it. Well, that's good so far, but we can go back to this and we can say edit Coca-Cola, and in this case, I'm going to create one more, which is, actually, let's do it this way. Let's take the Coca-Cola and take the Coke and copy that, in this case, to a Diet Coke.java, right? So let's edit the Diet Coke right now. So what does this become? It becomes a Diet Coke, and that becomes a Diet Coke, and everything else is the same. So we just have two different implementations right now. Now, what's going to happen right now? If I go back to Coca-Cola and module info, before I change it, if you look over here, you only have Coke. What happened to the Diet Coke? Not ready for release yet, right? So now I come in here and say, comma, and then I say Diet Coke. So essentially, you are adding to the list of provides. So you are saying, hey, in this module, I've got two implementations of my uh, soft drink interface, and those are Coke and Diet Coke, right? Those are the two implementations that I'm going to provide. So now if I go back here, notice you have Coke and you have Diet Coke. So that pulled in the two implementations for you because those are the things you have available. We'll continue a little bit more with this, but let's pause for a second and look at overall what did we do. What we did in this case so far is the following, right? So what we have is we have a client code, and the client code talks to what is called the soft drink interface. Then what we have is a implementation called the Coke implementation and the Diet Coke implementation. Those two are implementations of this interface that's available. And then the client said, I am going to use the ServiceLoader to go access the implementations of the soft drink. So the client says, hey, can you tell me what implementations are available? And the ServiceLoader says, look what I found. I found Coke, I found Diet Coke, and here you go, right? Gives an instance. So far, so good. Okay, let's dig in a little bit deeper into this just to understand a few things. Let's go back to the client code. And in the client code, I'm going to say over here, let's output got the soft drinks. So we will simply say got the soft drinks, and we will output that. So when you look at this, in this case, it says got the soft drinks, and it displayed that. But out of curiosity, right? So go to Coca-Cola and go to the Coke. And in the Coke, I say public Coke. And within the constructor, I'm going to say created. Let's go ahead and say over here, plus this. So I'm saying I created that Coke. And here comes a little bit of a charm. Look at the client code one more time before we go any further. Notice we got the soft drink on calling the load function, right? So line number 10 has the soft drink. Line number 12 says, got the soft drink. Then on line 14, we are iterating over the soft drink. But when you look at the output, notice what you see here. Got the soft drink, then the created function after that. So what does that tell us? That the instantiation is lazy. So it didn't go out and give all these objects, create them and say, here you go, everything is here. It gives you the benefit of doubt. You ask for the implementations, you take the first implementation and you're like, this is good enough, I don't need to look for anything more. You're not going to you're not going to create anything more, you save the trouble of it, right? So it's a lazy loading, and it's create the object only on demand. If you're not going to use something, it doesn't create it, right? So that's already baked in. Great. Now moving a little further in this, let's go back to this, and now let's go ahead and say I have a PepsiCo, right? And the PepsiCo com/agile developer, and in this case we'll say Pepsi is the package I want to create right there, and now let's copy the Coca-Cola up to Coke to Pepsi agile developer Pepsi.java. So let's edit the Pepsi class, and what are we going to do here? This is Pepsi, so we'll name it as Pepsi, and we are going to display the information about Pepsi, right? So that's all we have right now, and this is going to be a Pepsi as well. So far so good. Let's copy over the Coca-Cola module info to PepsiCo, edit the PepsiCo module info, and we'll call this one not as a Coca-Cola but Pepsi-Cola. And now we say it requires soft drink, but what does it provide? It provides Pepsi as implementation right there. So now let's go to the build one more time. And in the build, what do we want to say? We can say, let us run the client with 2 providers, right? We want to run that with 2 providers. So what are we going to do to run this with 2 providers? We can say in here, let's compile the Pepsi code and into PepsiCo.jar. We're going to compile that into that, and then we're going to run the client right after that, right? That's all we're going to say. So go back and run it. Ooh, what happened here? Coke.Pepsi is not a good idea. Let's fix that. So let's go to PepsiCo and go to Pepsi, and this is going to be, well, let's go to the module info, and in the module info, I'm going to say this one is going to be providing with Pepsi.Pepsi, right? That's what we are providing as an implementation. So when you run this, it pulled in Pepsi, as you can see. Now, one more small variation in here. So let's go back to the Pepsi example, and in the PepsiCo, I'm going to copy the Pepsi to, in this case, let's say diet Pepsi.java, right? So let's go to the PepsiCo and go to the diet Pepsi, and in the diet Pepsi, I'm going to return, let's say, a size. So then I say this is a diet Pepsi, and we will say that's a diet Pepsi also, right? So far, so good. Now, what about the size? I could say private int size equal to 10, just as an example. We'll start with that. You can go back to PepsiCo module info, and you can say I have a diet Pepsi that's available as well. So now if you notice here, we got a diet Pepsi on hand in the bottom. You can see that being listed. However, going back to this, there are times when you want to do something a little different. Let's say we have a public diet Pepsi, and that says I want to take a size as an argument. And I say this dot size equal to size, and I want to output the size. Now, this is a silly, trivial example, but let's take a more realistic situation. You have an implementation of an interface, but your implementation says my constructor needs to do some very complex things. My constructor is going to initialize a set of variables. Maybe it's got to run a certain process. Maybe it's got to read a configuration file. So there is a work involved in construction. Now, if I tell you I'm going to put a lot of code in my constructor, what would you say? Good idea, or rethink about it? Rethink about it, right? You don't want to overload a constructor with a lot of code. That's not a good idea. But I need some serious code to be executed when my object is constructed. What do you do then? You're telling me don't put that code in the constructor, but I need stuff to do before I finish constructing an object. What should I do? Bingo. Write a factory method, right? So a factory method, a static method, usually, and what does the static method say? You go to a class and say, create this for me. You tell the static method. The static method says, all right, hang on. I'm going to first create the object using a private constructor, and then I will run the functions I want to run, and then when I'm done with all of that, I'll give you the object. So it's not unusual to have static methods to create objects, and that's a common pattern we use in Java if you want to do complex things during object creation. So in this example, what just happened? It's not a complex constructor, but what do I don't have right now? My diet Pepsi doesn't have a no argument constructor. When you don't have a no argument constructor, the module system doesn't know how to create this object. It says, I cannot just pull a size out of thin air. I don't know what size means. So when you look at the output in the code right now, what you notice is an error. So it says, hey, look, it does not have a default constructor, diet Pepsi, error, I cannot compile this module, right? So what are we going to do now? What we're going to do here is we're going to say public. We'll say diet Pepsi, and this is going to be a static method. So we'll say static. Diet Pepsi provides a provider, and what does a provider method do? It says return new diet Pepsi, let's say in this case size 10. So in other words, either you give me a no argument constructor or you give me a static provider method. And if you give me a static provider method, I will use it. If you don't have a static provider method, you better give me a no argument constructor, right? So that's basically what you're saying in here. So now, if I go back and look at the output of this code, you can see in this case, it brought in Diet Pepsi with a 10. So you can see the objects being created on demand, and it was able to provide those. So we have two implementations, and the two implementations are able to bring those implementations for us, and we are able to use them, and that's what we are seeing here in the client. So far, so good. So now let's think about plugin architecture, how this would work. You have a core, and the core defines your interface. And your core also defines users of that interface. And let's say in the example I talked about earlier, a customer wants to place an order. Now you say, I want to give options for the customers to pay for it. So what does your code do? Your code says, hey, go look for payment options. What are the payment methods available? And the broker says, guess what I found today? I found they can pay through credit card. They can pay through bank transfer. Here you go. Give them the list of options they can use. Tomorrow, your company says, you want to provide them an option to buy now, pay later, right? And that becomes a payment method. And the customer is like, oh, what do I pay? Oh, there's an option to pay by credit card, pay by bank transfer, pay by buy now, pay later, right? And click on it, and then it says, yep, your credits are really good. You can pay later on, right? So that's the dynamic nature of what we are talking about. Now, having said that, let's go back to this code for a second. And in this case, we saw the lazy loading, which is really nice. But if I go back to this code and I'm going to output right now, let's go ahead and say reiterate, and I want to reiterate through that object. So if I grab those lines of code and I'm going to reiterate through those lines of code, I'm going to do a reiteration. Let's just simplify this a little bit. Let's go to the build.sh, and I'm going to just compile the whole thing, and I'm not going to bother to run it again. So we compile the client, and once we compile the client, I'm going to simply compile the next provider, then I'm going to compile the next provider after that, and then I'm going to run it just once in the very end. So when you look at the output of this code, what are you going to see? You see that you ran and you reiterated. What are you noticing? You notice that the first time you iterated, it created the object lazily. The second time you iterated, guess what happened? It never recreated the object. So not only is it lazy in its creation, it is also caching the objects. So if you are running through the code and asking for objects again, it simply gives you the objects, which is good and bad. It's good because you're not wasting time just recreating objects. You can reuse what you created. But what if there are more objects? What if I don't want to use that object? What if I want to get a fresh object? What do we do about all of those things? Well, what you can do to work through that is you can go back to your client code, and in the client code, you can say, rather than just reiterating, you could say reload and reiterate. So you can say soft drink start reload, and you can ask it to reload for you. So you're saying dump my cache and bring up the objects again as I need them. So now you can see it created the object first and it's creating the object again, right? So that's a reload option where you can reload it. So far, so good. All right. Now, this is great so far, but you know how some people are. They say, I want a soft drink, but I only want diet products. I don't want the sugary stuff. Give me the one that has less sugar in it, right? Fewer calories in it. So how do you query for things that you can use? That's one thing, right? Because you don't want all the implementations. You want only certain implementations. And how do you select them? So this is where you could ask for some flavors. But before we ask for it, let's revisit this problem. So I go back and get the soft drink, as you can see here. Now, looking at the code I just wrote a few minutes ago, you are looking at this, and I know some of you are thinking in the back of your mind, okay, he's using a for loop, but why not use a stream API to do the iteration, isn't it? What about a functional style looping? Wouldn't that be really nice? So what I can do here is, I can say soft drinks, I'm going to get the soft drinks, dot stream, all right, you got a stream, for each system.out print line. So I want to print out what I'm getting from the stream API. Now, there is a difference between a regular or imperative looping and a functional style looping. In the regular imperative style looping, you are getting the implementations lazily. But in the functional looping, you're not getting the implementation. What you're getting is what are called the provider. So you have one more level that you have with you. The easiest way to see that really is to look at the output of this code, and what does it say? You got a provider, 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 provider. So those are the providers that were given to you. So what are we going to do now? I'm going to say a dot map, and given a provider, return a provider dot get. So I want to return an instance of the provider back to the caller at this particular time. So when you look at the output, you have a class Coke, a class Diet Coke, a class Pepsi, and a class Diet Pepsi. So this is returning to you the implementations of the interface. Then, as you probably know, you don't have to use a method, lambda expression, when you can use a method reference, right? So I can say a service loader and then a dot provider, and on the provider, I can simply use the get method on it. So I can simply use a method reference like so. So that becomes a nice concise code using the functional loop, isn't it? So then what am I going to say here? Now that I got the provider, I can do a map. And on the map, what am I going to do? On the map, I'm going to say, well, now that I have a provider, I can say, pardon me, the service, the soft drink, I can say soft drink, and this can be a soft drink dot get name, right? I want to get the name of the soft drink, plus, and we could say a soft drink dot get size, and I want to return the size of that particular soft drink. So we are doing the map to get that information. So so that's basically what we are getting right here is the object through that particular iteration. So, soft drink, again, the uppercase D as I wrote here. So let's run through that. And what are we seeing here? You can see in this case, we got Coke, Diet Coke, Pepsi, and Diet Pepsi. And the object is created as you iterate over it, right? Now, you say, what's the benefit of doing this? It seems like we did more work, not less work, right? But you could say, but it's functional style. And there are people like that, right? Who have drank the Kool-Aid and they would rather write functional style code. Have you ever seen people like that? Yep, you see one of them here, right? That's me. I'm like, oh, look, I can write this code in functional style. Isn't that beautiful? But you're like, dude, you just wrote more code. Why do you want to do it? Yeah, but it's beautiful. But you wrote more code. Yeah, but it's elegant. But you wrote more code, right? It's like, but I like functional style. Bottom line, if you don't have a benefit, don't do it. So do we see a benefit right now? No. So the imperative style iteration is as good or even better than the functional style. But having said that, what if you want to do something a little different? So you can say, let's say in this case, a filter, and guess what you can do with the filter? You can take the provider, and on the provider, you can say provider.type. So the provider.type, this is the place where
it might have an advantage using the functional style. So you're saying, wait, don't give me the objects yet. Before you give me the objects, I want to inspect the metadata. So you're saying, give me the provider's type. So what is the type of the provider? It is the actual class that you're going to work with. And then you can say, for example, dot is annotation present. And you can then say what kind of annotation you are expecting. So maybe, I haven't done this in this example, but maybe I will annotate all my diet products with a dollar low calorie. So then here I can say, only give me low calorie products, not anything else. Similarly, you could say, in your application, you could say, give me all the payment methods, but only credit payments and not anything else. And that might give you only credit payments. Or give me only debit payments, not anything else. And somebody may pay with a check, somebody may pay with the bank transfer, whatever that could be, right? So the point is, you could start filtering out based on the metadata. You could look for annotation, you could look for something else, right? Annotation is more logical because you can clearly specify that in the code. It's a clean code and you can get access to it. But on the other hand, if you're looking for other kinds of metadata, nothing stops you from doing it because you got the type, and then you can go back and access whatever you want to do from the type, and you can do that at this particular point. So what's the moral of the story? The moral of the story is, when you look at the client code simply says, I want all the implementations of an interface, right? That's basically what the client is doing. Is the client using reflection? No, right? So do I have to deal with a monstrous amount of exception around it? It's clean cut code, right? And you're like, hey, I want implementation of the interface, give it to me, and it's given to you, right? So very clean code, that's what you saw here. But clean code doesn't have to be insecure code. So as a result, when you look at the a soft drink and look at the module info, what does that say? It says, I am going to export from here a soft drink package. So anyone can use my soft drink package, but that's just a bunch of specification, my interfaces, right? That's all I provide, nothing really exciting. Then my client module info says, I am a user of this interface. Hey, broker, when somebody makes a request for implementations, I grant you permission to give that. Without this, you will not be able to see that information, right? To request for that information. Then you look for the Coca-Cola module info. What does that say? It says, I'm not exporting my package, right? I'm not exporting my package. But what I'm doing instead is that I am going to tell that I provide that implementation. That's what I'm doing, right? So I provide that implementation. And so this says, my package has multiple things, but that's not for you to use. That's my internal stuff. You have access to just one small window, which is those two implementations of my interface. And you can use those two, but you can only use them by way of ServiceLoader. You have no right to ask for it at compile time. So if any code says new com agile developer coke.coke, that will be a compilation error. It's going to say, what are you doing? You're accessing some stuff that's not given to you, right? You have no access to it. So this is available not at compile time. This is available exclusively at runtime. And what's the benefit of that? It removes tight coupling. It forces you to use IOC, dependency inversion, a very clean design, not just a clean code, right? So from the design point of view, as an architect, as a technical lead, you can do the design and tell your programmers, let's go, let's implement it. And you have guarantee that they don't violate it. They don't sneak around and you're like, wait, doing code review. It's like, dude, what happened here? Doing a new of this, how did this happen? Well, you don't have to code review. The compiler is watching that. And the compiler says, sorry, you can't do it. Why not? Because the person who wrote that module never gave you permission to use it. You can sleep well that night, right? Because if I come along and say new, the compiler is like, no, 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 no. She never meant for you to call that directly. He never meant for you to use that code directly. Timeout, you cannot access it, right? So that's the benefit you get out of this. Now, not only is this available to you at compile time, you have this information available to you at runtime as well. So how is that working? So if I say a jar minus d minus f output lib, and let's look for soft drink.jar, what does it say? It exports the soft drink, right? That's what it says. And it exports a soft drink, that's it. That's just a spec. But on the other hand, if I say, tell me what the client is expecting, it says in this case, ooh, where did the client go? So the client module, it should be giving me the details in here. That's kind of strange. I expected the client to have a descriptor as well. So, but for some reason, let me look at the client. This is kind of a little nerve-wracking. Module info.java is there. So let me make sure that this is actually built properly, right? So let's go ahead and look at the output libclient.jar. So right there's the client. I'm going to examine that one more time. That kind of bothers me. Something is wrong here. But anyway, you would have seen uses being described in there when you see the output. Similarly, if I say jar minus b minus f, output lib Coca-Cola dot jar, what does it say? It says it requires the Java base, requires the soft drink, but it provides the Diet Coke and the Coke, right? That's what it contains. It provides the Diet Coke and the Coke, but it only contains the Coke package, but it doesn't export it, right? That's what you're seeing here. So essentially, that's the contract. So you cannot directly use the classes. What you can do instead is, you can use this only through ServiceLoader API, right? So that's basically the interaction. So the idea is, they defined this module structure. They gave a very clear contract. You cannot use what you didn't require. You cannot use what's not exported. And that works great 99% of the time. Better encapsulation, clear definition of boundaries, really good description of the dependencies. And all that is great most of the time, except when it comes to plugin, we need the dynamic discovery. Dynamic discovery is not possible with the module system that we wrote, but the service loader makes that happen. So the module system now says, let's not export, instead let's provide. And let's not require, instead let's do uses. And as a result, that binding the contract, the broker can happen behind the scenes. That's all I have. Hope that's useful. Thank you.